We're still in Chapter 2, Section 2.3. We're going to talk about inequalities. Equations and inequalities is what we've been dealing with, but this one's going to be doing both the addition property and the multiplication problem when we solve equations. We're also going to decide about like terms, collecting right terms, and we're going to talk about moving parentheses and working with equations that have an infinite number of solutions, and that's when the inequalities come in. We'll talk a little bit more about that as we go along. So let's look at our first problem. It says to solve 9 plus 8x equals 33. Well, the first thing you want to do is you're still trying to get this variable completely alone, but it's got something being multiplied to it, and then it's got something being added to it. So the first step is to undo the addition. So I'm going to subtract 9 from both sides. That makes that 0. So now we have 8x equals 33 minus 9, which gives me 24. The next step would be to divide both sides by 8. So x equals 24 divided by 8 equals 3. Now go back and check your work. This is the best thing that you can do, is to go in and check and see how this goes. So if I say 9 plus 8 times that 3 that we found equals 33. Remember, order of operations, we do this first. So 9 plus, whoops, put an equal sign there, didn't I? Plus 24 equals 33. And then 33 equals 33. It checks. So x is our solution. So it's true. Our next example, again, we have 35 subtracting some unknown number, which is represented by our variable x, equals 27. So I'm going to subtract 35 from both sides. So now that leaves negative x on the left side, and then 27 minus 35 gives me negative 8. Remember, you can't have a negative right here, so we need to clean that up. So if I divide both sides by negative 1, that makes this go away, so we have a positive variable. And then negative 8 divided by negative 1, those negatives turn into positives, so our final answer is 8. Again, you can check your work and see 35 minus 8 equals 27, 27 equals 27, so yes, that is correct. Now, sometimes you have to combine like terms. So if like terms appear on the same side of an equation, we combine them and then we solve. So you look at one side of the equation first, see if there's anything you need to do. Then you look at the other side, and that's what it means if it appears on both sides. We're going to look at both sides, see what we can clear up first, combine like terms, and then we start the solving process. So let's do a couple. So here's this one. We have 5x plus 4x on the left side, so that gives me 9x equals 36. And if I divide both sides by 9, that gives me x equals 4. And you go back and check that. You can check it with the original equation, or you can check it with what you worked with. I have a tendency to go back to the original equation, that way it's less mistakes. So if I say 5 times 4 plus 4 times 4 equals 36, I get 20 plus 16 equals 36. 36 equals 36. So it does check, so 4 is our solution. Now this one again is represented with a negative here. So we need to gather like terms on both sides. It looks like we have things here. We have a 4x and a 6x on the left hand side. So that gives me 10x. Oh, I'm sorry, it's a negative x, isn't it? So that gives me a negative 2x. Be careful of that. You'll probably do the same thing I did. Plus 7. And then on this side, we just have the two constants that are together, which is 22 plus 3x. Okay. I have a tendency to get my variables on the left-hand side, so I'm going to subtract my variables first. I'm going to subtract 3x from both sides. So that gives me a negative 5x plus 7 on the left side equals 22. Because remember, those go away. I'm going to add 7 to both sides. Oops, sorry, subtract 7 from both sides. Let me undo all that. See if it'll let me do. Nope, because we're recording. So I'm going to go in and fix this with my little pen. We're going to subtract 7 from both sides. So when we do, we wind up with negative 5x on the left-hand side still, and then 22 minus 7 is going to give us 15. Divide both sides by negative 5, so x now equals a negative 3. And you can plug that back in to see if it works. I don't have room, but I want you to go back and try it and make sure that we are correct. So x is negative 3. Let me write the final answer here so you can see a little bit better. Now, sometimes we have fractions and decimals, and this is where a lot of people get confused. You have to look at both sides. So, in general, equations are easier to solve if they do not contain fractions or decimals. And I think of it this way. Sometimes I'll go get a pie, and I'll cut it up into pieces to make it easier to serve. And so that would give everybody a piece of pie, but it's still one whole pie as long as I don't take it out of that pie pan. So what we're going to try to do is try to make it easier and clear fractions to work with, okay? And sometimes we're going to clear decimals too. So let's see what we can do on our first problem. Okay, you can clear decimals by multiplying by the highest placeholder. Like this one has 7 or has 2 decimals to the right, so you can multiply by 100 and that would clear them all. If it's me dealing with a calculator, it's going to be easier for me to just punch it in the calculator. So that's what I'm going to suggest you do. If you want to know how to clear it by hand and using the decimals, we'll work on that together too. I have no problems doing that with you guys. So, but the first thing I'm going to do is I'm going to subtract negative 18.4. So I get negative 6.2y equals 7.24 minus 18.4. That looks like an awful 4. So that gives me 11.16, and it's negative. And then I'm going to divide both sides by negative 6.2. So right now that tells me my answer is going to be positive. So if I say 11.16 negative divided by negative 6.2, I get a positive 1.8. So let's look at the next one. We've got a couple of things that we need to go on. We need to distribute here. So let's start there. First we're going to distribute here and here. So I have 9x equals 45 minus 6x, because you have 3 times 15 and then 3 times negative x. I think of Mario, who's got to hop through all of it. So I'm going to add 6x to both sides. That clears it on that side. So now that gives me 15x equals 45. I'm going to divide by 15, and x simply equals 3. So this was using distributive law, so it worked very well for us. General rules for solving an equation. Here's the procedure. Multiply on both sides to clear the equation of fractions and decimals. This is optional, but it can ease your computations, your calculations. And if parentheses occur, remove them using distributive laws. Collect like terms if necessary. Get all terms with variables on one side and all numbers, what we consider the constant terms, on the other side. Using the addition principle, collect like terms again if necessary. Multiply or divide to solve the equation using the multiplication principle, and then check all possible solutions into the original equation. Okay, so let's start this one first. Let's look at the left side and see what we can clear up. So I'm going to clear up here and here. So now I have 3 minus 8x minus 48, because negative 8 times x gives us negative 8x. Negative 8 times 6 gives us a negative 48. Then we're going to do distributive property here and here. So I have 4x minus 4 minus 5. Remember, this is outside the parentheses. Now, I'm going to gather like terms on the left-hand side. So I have 3 minus 48. So that's going to give me negative 8x minus 45. And then I'm going to look on the right-hand side. I have 4x minus 9. I'm going to subtract 4x from both sides. I have a tendency to move my variables first. So I have negative 12x minus 45 equals negative 9. I'm going to add 45 to both sides. So now I have negative 12x equals negative 9 plus 45 equals 36. Let's bring this over here where you guys can see. So now I have negative 12x equals 36. We're going to divide both sides by 12, a negative 12. So now I get x simply equals negative 3. Remember, you can plug that back into the original equation and it should check back out and be just fine. So let's work another problem that is very similar. So we have 8x minus 18 on the left-hand side. We have 6. We need to distribute this 8 through here to clear those parentheses. So I get 8x minus 24. Can't gather anything on this side. Let's look on the other side. I have 6 minus 24. So that's going to give me a negative 18. I'm going to subtract 8x from both sides. So that gives me negative 18 equals negative 18. Uh-oh, where did our variable go? Yeah, it disappeared or it canceled itself out on both sides. If this is a true statement, and it is true, then we have infinite many solutions, okay? Infinite many solutions. This is called special solution. So your answer would be all real numbers. Didn't matter whatever you plugged into x, it would balance it out and it would work every single time. These are special cases. So let's look at the next one. We're going to do distributive property. So we have negative 4x. Whoops, let me start on the other side. Let's do right procedures here. Again, I have negative 4x times those two in the parentheses, so negative 4x, negative 4 times x gives me negative 4x. I think I said it wrong. And then negative 4 times 6 gives me negative 24. Then we're going to distribute here and here. So we get negative 4x plus 4 minus 3. We're going to gather like terms. I have negative 4x minus 21. And on the right hand side I have negative 4x plus 1. I'm going to add 4x to both sides. And again, our x terms disappear, but this time we have negative 21 equals a positive 1. Is that a true statement? No, it's not. Very good. It's false. So our answer is no solutions. You can never solve this equation to make it balance on both sides. In class, we will practice a problem that deals with clearing fractions. We did do it on here, so we will practice one clear in class, so remind me to make sure we do that.